So let's continue now. I can get myself on the big screen. Maybe you can zoom in on me because I want to show you something. If my microphone is long enough, yes. In the background, you see my beamline, and it is the icon beamline. And actually, what you see here is the X-ray source, and then you have the neutron beam, which comes from this way. So this is all the setup that I'm working with when I'm doing my bimodal experiments. So just a little short note on my working place. So let's go back to the lecture again. And let's talk about data frames. So this is a technical part. And as I already announced, we have been using data frames throughout the lectures and also in some exercises, but they were never really introduced. So this is what I promised I would do. And first of all, we have our workflow with some image analysis, extracting features. And in the end, we want to present it. So we have all the input data, do all our fancy algorithms, and then we want to process it. And here we got the nice plot out of it. Now the question is how to store the data while we are working. Storing afterwards, well, then you probably have some data formats, maybe even CSV data, so comma-separated values, possibly Excel sheets, I don't know. So CSV is actually a kind of Excel sheet because it's tabulated data. But in the computer, we can store how should we store the data? And first of all, we have different options. In Python, we can have one array per feature. You can also have a list of data structures or dictionaries. And the operations you want to do on these data lists is some counting, statistics, possibly select something, cross selections based on values in that table should affect the selection of values in the other table. For example, you may want to do some transformations of the data. And of course, you want to visualize the data. So if we have a custom solution, it's very time consuming because you have to implement a function that does something for each operation you want to do on the data. And there is also possibly little flexibility in how to work with it. So once you have implemented one analysis, it's difficult to bring it over to the next structure of data. And there's also a big risk of doing mistakes, so it's error prone. So this is where the data frames come in, and we have been working with them already in some sense. But what a data frame is a container of data. It's organized kind of like a spreadsheet in columns and rows. And it can take any data within the columns. So you can be pretty wild about what you put in. Should, however, be a little bit strict in what you put in, just to don't make a mess of your analysis. So what you can do on these data frames is apply selection filters. You can sort the data in the rows. You can perform arithmetics with the columns. Can also compute the statistics. And important is also you can read and store into files or databases. There are even connections between pandas and SQL databases, which you can use for your storage. So it's really, call it a combination of a local database and a local spreadsheet in your program. There is a lot of documentation. So there is the main pandas documentation, and there is also getting started with pandas as tutorials. And with those, you can get I think you get pretty good started on how to work with pandas. But anyway, I will give you some first, say, a little starter on how to work with them. So the first thing we need is to create a data frame. It can be done from a dictionary, can be done from a data file, can be done from a NumPy array, can also be normal lists. But the first we have to do is to import pandas. So typically pandas is imported as PD. That's, say, the typical naming for pandas. So let's execute that one and go to the next slide. And now we want to create a data frame from a list of dictionaries. And that's a typical use case when you start creating a data frame based on image feature properties or something like that in from your images. So I think this is almost an example of what's happening in the data labeling and image properties lecture. So what we have, we start with an empty list. So DL is data list. We loop over some items in the image, and then we append these small dictionaries. So position gets the value I, and the column sign gets the value of sign of I. Once we have made this list, we can add it into a data frame. So that would be PD data frame and DL. And when we execute this line, we get a table of positions and sign, and then we have the row numbers here, the row indices here. So this is our first very basic data frame. And then we can also, of course, read in from a spreadsheet, in this case, CSV spreadsheet. I have noticed that sometimes when you export CSV from Excel, it can be operating system dependent or actually language dependent. So which localization you have set on your computer. It may produce commas or dots for separating the integer values from the fractions. And that's a bit annoying. So pay attention to how the CSV files are created from, for example, Excel. So let's load some data. And now we get a pretty long table here. This is actually the data that will be used in the exercises. And compared to the previous slide, I did a little change here. Here I use something called sample. It selects 5 rows randomly out of the data just to get an idea of what the data looks like. In the previous slide, I used instead, I used the head. Oops. And with that, oops, typo, sorry. With that, we get the first 5 rows. And you can also type in 10 here, and then you get 10 rows. Within this, you can also slide, so you can see the whole data set. In some cases, it's too many columns, and then it's introduced with dots like this. So let's bring it back to the, oops. So also here you can say you want selection of 10, how many you want. For saving data, you can use the same concept. So here you do the data frame to CSV, and then it saves it like this. There are different file formats. I saw on Medium someone who compared different data formats. Which you choose depends a little bit, again, on what is the purpose and how big is the data. If you only have small files, small amounts of items, CSV is just fine. It's easy to work with. You can import it easily in Excel. So it's or any other spreadsheet program for that matter. But if the data is getting really big, talking big data, then CSV may be a bit too slow. If the data is maybe also more complex, so you have possibly sub frames within the frame, then you have to maybe consider something else. So there are different file formats that are considered. One is called Feather. Then there is the HDF5. And then there is also, there was a question. No, my chat doesn't want to appear. I lost my chat. Hello, chat. No. No.
The question is it possible to have a column bifurcation? I mean, for each column name title, have 2 or more columns within.
I am not sure, actually. I usually work with this the simple format. For that, I actually have to direct you to, well, our big friend Google or something like that. Probably in Stack Exchange, you can get answers on that. But in principle, why should you have 2 columns within a column? That is the question I would rather put. What I usually do is if I have several items, then I would actually add another column where I put the item name or label. So in this data set, for example, there is the, let's see if you can see it. I think there is somewhere, yes, out here. We have the ID, and that's the identification of the object. And then I can have different, if I, for example, would run a parameter scan, then I would have a column for each parameter, and in many of the rows, you would have the same parameter value. And then you can do selections out with the help of filtering and extract the data in that sense. So multiple columns of the same within a column, I'm not sure if it's possible. So I don't know, actually.
Yeah, thank you. It was because in one image, sometimes I have different regions of interest, let's say 3 to 5. So the image name remains the same, but I would like to see the transmission values for each region of interest.
Yeah, but if you have different regions of interest, then you would create a column, region of interest. And then you have an ID number. So you have file name, and then you have ID number for region of interest. And then you can have a lot of properties around each region of interest.
Yeah, but the way to solve it, also someone suggested in the chat to have multi-index. I will search for that.
Yeah.
Yeah, both of them are good solutions. Thank you.
Also, during the work, you may want to add a new column. So that would be, in principle, very simple. You, if the column doesn't exist, you just say data frame, the new column name, and then you create some data. And this data is created already using information in the other columns. So here I create one is sign, and the other one is sum, and the sum is the sum of 2 columns of the data frame. So our previous simple data frame was only the position and the sign, and now the new one has 2 new columns added to the data. And then we come to the topic filtering. Now I want to create a selection of data. So what I select is all the rows in the sign column, which are greater than 0, are selected and produced into the data frame 2. And maybe I should, then I can actually look at the whole one. And then we can see here that we have only positions 1, 2, 3, 7, 8, 9, where the sign is all positive. What the other two are doing, it doesn't matter, because this is what we selected here. Then it could be that when we load data that, well, the name of the column is not really what we want to have. It doesn't really make sense in the big, or you may need to rename it, because in one it's called item label and the other one is only called label, and you want to rename them when you want to merge two data frames or combine them somehow. So the first one, we create a little data frame here with A and B. And now we want to rename the columns into something new. And then we rename A to hey and B to hop. And then afterwards, after this transformation, we have new column names. So it's possible to just select, so it would be a dictionary here with the different original names of the columns and the new names of the columns. No. So until now, we have only been talking about creating, renaming, etc. But we also want to do some computations based on the information in the data frames. And it's very easy to compute statistics from the data frame. You can compute the mean, standard deviation, min, max, median, if you like. And just here I have the mean. So if I just take df.mean, it computes the average value of all the columns. That may not make sense always. So we can also do selection and filtering. For example, if I would do here, I could take just let's see, the sign, and then I would just get the value of the sign column. Another option is to work with describe, which is doing a little computing everything for you in one command. So then you get the count, how many items there is in each, the average values, the standard deviations, minimum, maximum, and the different quantiles of the data. So you get all that in one single command. Can be pretty helpful for getting a quick overview of the data. Of course, as I said, you can select a column, but you can also do filtering. So here we can look at the standard deviation of the sum when of the rows when of the all columns when the sum is greater than 0. So this would be the output of that one. If this makes sense in this particular case, it's more a demonstration, but it shows that you can do filtering and then compute statistics. So for example, if you want to have something like selection of all items in of a certain size, then you can do a selection on the size variable and looking on different variables afterwards. You could also do, for example, here you can add. Oops. We just want to look at the sign standard deviation when the sum is greater than 0. And no, I forgot one. Yeah, I forgot one. Sorry. So then you can compute things like this. So I think it's a very powerful tool to extract statistics from the data. Sometimes you could produce a new data frame based on calculations you did on one data frame. So it moves around. It depends a little bit of what you want to create. Of course, when we have data, it's always nice to plot, and you can use the columns of the data frame directly in a plot. So you can do something like the normal matplotlib plot, column A, column B, etc. But pandas already support plotting functions built in. So then we can create a new plot like this. So if we do just plot of the data frame, then it plots all the columns like it did before when we computed statistics. We all computed the statistics of all if we don't specify which one. So it's maybe not really useful. For example, the position is just a straight line, which doesn't make sense in this case. So we need to do something else. And with that, we can select different, there is a typo. We can select a couple of different plot types. So here, let's execute this one. Now, in this case, I'm plotting only the sine column. And of course, we get a sine curve. This one, I select to plot the sine as together with the cosine. And if we combine those, we get naturally a circle. And the final one is just taking the x column as the position and the y column as the cosine, and then we get that result here. Oops. Yeah. Nay. So, and then we can play with different plotting styles. There are different ways of doing the plotting. Not only line plots, but we can also do bar plots or scatter plots. And well, there's a lot of different options for doing the plotting. And the interesting thing here with a bar plot is you can see that the columns, they are plotted together with each other. So you have a collection here of all the columns. So if you would have different samples in different columns, then you would create a bar plot based on that, like that. Yeah, scatter plot, well, right now it's also outlines the circle because that's a sine and cosine combination in this case. And then we can also do some set operation with the data frames. So if you have two different data frames, you can, and you want to combine them somehow, there is a nice tutorial how to merge data frames in the pandas documentation with a link here. But just to show a little bit how to do it, we have data frame A and data frame B with a lot of values. And if you combine those two, we get, of course, the list which are combining them. But there is a little problem that the index is repeated, because when you create these, they get automatically the index 0 to 3. And when you combine them, these indices are not updated. So that is a bit confusing. And the way to get around it is to actually provide the index when you create a data frame. And then when we run this, you can see that the row numbers, they are correct now. You can, actually, I didn't try that out. You should be able to change the indices also afterwards. But I haven't tried that out actually, but there is a way to change the indices. The other one is, so now we had just the method of adding rows on top, stacking them on top of each other. But if you have two data frames with different contents and you want to merge them together on the side by side, then you need to do a different approach. So here we have different IDs and different indices. And let's see how we can merge those. And you can see here that we have different IDs here and we have the indices. And they are combined, let's see, 0 to, so the index 4 is dropped for some reason. Yeah, because they got the same ID. So that is something you have to look out for so that you don't overwrite the same values. And in this case, what did it take? Index 4, no, index, I just showed the head. Okay, maybe I should show the whole thing instead. That doesn't matter. Okay, let's go on. We can also create a data frame from selected columns. Sometimes if we have a really large data frame, it's, as you could see in the previous example with the data that we will use in the exercises, there was these 4 dots and something was hidden, and there is usually a lot of information in a data frame that you don't need for the moment, and it's more clutter in your preview of the data. So then we can instead create a new data frame based on a selection of the previous one. So here I have the result data frame from the previous, and now I'm only selecting the columns A, C, and D. And when we look at that, we actually just get those columns extracted. And that brings us to asking, when are the pandas data frames useful at all? It's several times pointed out that pandas is useful for large data, but not big data. The main criteria is that pandas need to fit into the local memory of your computer. If it doesn't, you can't use pandas. If you want to work with really big data, then you need some kind of parallel distribution data frame that partly is stored on disk. Then you can use, for example, the Dask data frames. But how is it now with the big quantitative imaging? Do we really produce big data that is stored within a data frame? I would say mostly not. The big part of it is the image data, which can be terabytes of data. But as soon as you start segmenting, you have already reduced the data a lot. And when you extract the feature data, you have reduced it, like you identify in this terabyte, you identify maybe some 1,000 data points. And those are easily handled with a pandas data frame. And then, of course, when you go to a higher level of abstraction, looking at statistics within groups, between groups, then the data is reduced even further. And finally, the model is also further reduced, and you only have a few model parameters that you have fitted. And then it's no problem at all to store that in the pandas data frames. Maybe you use information from feature data in your modeling, and possibly you don't even put the model parameters within the data frame. I don't know. Maybe you think it's convenient to have them there, then by all means do it. But otherwise, maybe it's just a single value that you extract from or something you use in a further analysis somehow else. You can, in principle, store images within the data frame, but think twice before you do it, because it soon pretty fast explodes in a lot of memory usage. What could make sense is if you have extracted items, then you could extract those little items as small sub-images. Could make sense. Or else you just store the region of interest parameters within the data frame and access back to the images. So that is a little bit a question about what is convenient for you. What extra coding do you need to do? Why would you put images within this data frame, that is for you to decide how much you want to put images within the data frame. That brings me to the end of today's lecture. The second part was a little bit shorter, but I hope you find it useful. And also the links that brought us, that I provided, I think there is a lot of useful information in it. I think the pandas documentation is pretty well written. It has a lot of tutorials. And with that, I believe you can really get good started on working with the data frames on your own. So today I've been talking about working with different modalities, how we can add more information from different imaging sources in order to provide or improve our conclusions based on the imaging experiment. We also can add components in the analysis workflow or in the qualitative visualization workflow. The whole idea that we have two modalities requires that we have some kind of fusion. Just showing them parallel between each other is not really fusion. So we need to do something that blends the two modalities together into one conclusion in the end. If you work in parallel with the data, we could say that you do a decision fusion at the end once you have done all the analysis of each modality. It's a possibility, but I would prefer doing the fusion a little bit earlier. That's my personal choice, but depends on your experiment and what you want to get out of the experiment. Data frames, I think, is a very useful tool when you start working with it. It's much easier to work with a data frame than to have a lot of arrays. And it helps you to organize your data in a better way, and also easier to extract information that you need for your experiment. So with this data frame, you can do column filtering, you can do arithmetics, you can do plotting. So I think it's a very useful tool. So I think that was all for today. And I have still a few additions to do on the exercise. So give me the, say, the afternoon until you start doing the exercises. So thank you for today.